question, how do we build a building? We typically make a utility core and build everything around it. So if I have a cross-sectional view of a building with a utility core and I have all these offices around it, then I limit my distance for all the utilities to these rooms. If I had my utility core on the outside of the building, because it doesn't take up any space there and I can sell this rental space here, then I maybe short there, but much longer over to here. So I've increased my utility runs on everything. So it costs more money to operate and to build when you do it that way. So I'm thinking, well, if that's good for commercial, shouldn't it be good for residential? So again, I'm not a sketch artist, and I'm not a house designer, but I did stay at a Holiday Inn Express last night anyway. So I can't really sketch out, but you can imagine the profile of a house where you had the long axis, east-west axis, and you had a utility room off to one side, but then next to it was the kitchen. Next to it was a public bathroom. So you have a laundry room and utility room all in the same place. So that is a wet wall, that's a wet wall. All your water stuff is all in one place. Your air conditioning utility is in here. Your ductwork that goes to your kitchen is right through that wall. Ductwork in there. A great room might be right across from here, a big great room here. And then you might have the bedroom hallway, where you come down here off to the bedrooms, where you typically do that in house design. Now, what is the height of the ceiling in a typical house nowadays?
8 foot.
8 foot, but we get to be more fancy these days, and you do 9'4". And then you have 8 foot back in this hallway into these bedrooms, so this looks nicer up here. What do I do with that extra 1 foot 4 inches?
Throw a fan up there?
I actually have a drop ceiling, so to speak. I can put sidewall diffusers here to get the air conditioning over here, and I can put my ductwork in that differential space from the 9'4" to 8 foot. I can put my ductwork right in there and have all my ductwork inside conditioned space, which is not up in the attic and being too hot. So if I design everything right, I can pull out my ductwork in more convenient space for its cooling job. I can limit the lines for my plumbing. I could actually go in and build a slab. If I do a cross-sectional view, I could build a slab 2 inches down, right in that laundry room, and put a drain, such that if I ever had a failure of water in that utility room that has 75 to 80% of the water connections in the house, I can put a drain in there. I can blow any pipe you want. All I can do is tile the floor in the laundry room and put 2 courses of tile up the wall. Sink, and I got a drain in there, the water can flow out there all day. You come home from work, you've blown a water line, and it's no problem at all. Many houses in Gainesville are built where the slab all the way through to the garage is one level. So if I put the water heater out in the garage with no pan on it, and I blow it in the garage, I got water in my house. It's a flood, it's an insurance claim. So you can go through all these things, whether it's electrical wiring or water. I can look at it a different way, limit the lines of my service for water and electric, minimize material purchases. Then if I concentrate everything, I can afford to put protection devices. They've got, in fact, we just talked about that this morning. They've actually got a system where you can put a water sensor in the floor of your laundry room that senses when you have water coming across the floor, and it sends a signal that shuts off the water to your house. Oh, wouldn't that be cool? Now, how many of you ever lived in a house with a water line break? Does that happen to anybody? Ooh, lucky. Statistically, very unusual. Usually there's 1 or 2 that have had that happen. There was a time period in the 70s after the first energy crunch where one of the ramifications, because they were also building a lot of houses, was they went cheap on the copper, and they bought, there was a very cheap version of copper that had a tendency to get pinhole leaks in it. And for years, in many houses, you come home and all of a sudden you have a pinhole leak. And what happens to high pressure water on drywall? It just goes through it, yeah, eventually. And so you hear a little noise, and what's that, And And then after a while, the water just comes right through the drywall. And so that was a water leak. So, again, might be electrical is the topic, but the tie-in is a systems look at everything you're doing. Everything you're doing, whether it's water, electrical, air conditioning, cows, growing blueberries, it doesn't matter. It's all a systems-wide look at everything. So that's, in a nutshell, chapter 6. We've got the homework, which is problems 1 through 5. Yes. 1 through 27, no, 1 through 5, due on Friday. This was kind of an example of the putting all of it together as separate problems on the range example, calculating the range, on the general lighting. Again, don't forget when they say required circuits, they're talking about bathrooms, laundry rooms, and 2 in the kitchen. And so if you have 2 bathrooms, you have to make sure that you count that second bathroom. And don't forget that for required circuits, only an example where you have 1 bathroom. So anyway, that's chapter 6. So after we go through chapter 5 and chapter 6, we could wire up anything. Right?
Yeah.
The only problem is digging a ditch. Will?
The minimum required, I think, is 4. 1's the kitchen,
Yes.
laundry room, and bathroom.
Yeah.
Okay.
4 required would be the example where there's only 1 bathroom.
Yeah, but that's a minimum. You have to have a.
Right, right. Because a house has to have a bathroom.
Okay.
Does it have to have a laundry room? If you have a laundry room in the garage, it's still, you know, you kind of
Yeah, I
split it.
just, yeah, I
Yeah.
assume that.
Yeah.
That's what I was asking.
Yeah. Yeah. All right. How many have ever had the laundry room in the garage? Right. Bought a house. They had the laundry room in the garage. They cleaned out all this stuff. They built the house for them. That's when you realize there's all kind of people in this world. They built the house for them. They moved out, and that's when I realized they never put the dryer vent in the garage. No dryer vent.
What?
Yeah, they didn't put a dryer vent in. So when you take your washing and dryer out of the garage, what's in the corner?
Oh, giant
8 years worth of lint and cockroaches.
Cockroaches.
Oh, they love garages, lint, moisture. Oh, the humidity coming off the dryer. Oh God, they love that. Oh, that was a condominium. Oh, geez. Now, here's the engineer that's not a housing expert. At least I wasn't at the time. I've learned a little since then. You want to put a dryer vent through the concrete block wall? So you take the concrete block wall and you bash a hole in the middle of it, right? He got it. No, there's a webbing right in the middle. You go off to either side. You know, concrete block has 3 walls on it, the outside walls and a middle web. And I'm like, man, I'm not getting there. I've seen guys bash this and it goes right through. I mean, I know I'm a small guy and I don't have the big ham-fisted muscles, but I should have been through long by now. Yeah. And I got, oh, right. And then you look around to see if anybody's watching. Crap.
Play Jenga there.
So, anyway, yeah, go off to the side. Go off to the side. You learn these lessons the hard way. Right. So it's like my won't tell that story. That's too funny. Anyway, we will see you all on Friday. For those of you that are in Dr. Kuiper's class, there's no class today. You've got assignments from Dr. Schultz and Dr. Kuiper you can work on. Pass the word on that. You will come to class on Monday in that and be introduced to Dr. Price. And he will probably pronounce it differently. Everybody calls it Price, but I think the actual pronunciation is a little different. But anyway, he'll tell you that. Very cool stuff. He's got to pass the word. He's got it going.